and I'll be taking this Hadoop demo session today, and I'm not sure because I'm not able to see you guys. So wanted to know a brief background about uh, about your prior work experience, or what is your expectation out of this Hadoop. So Satish, can this be a two-way communication, or it will be just like I'll be speaking and that's it?
It's a two-way communication. They can speak actually. Okay.
Okay, they can respond. They can respond, right?
Yeah.
Okay. Yeah. So wanted to know from you guys, what is the expectation out of this course? Is it from Hadoop development, or what perspective you guys want to take up this course?
Yeah. So basically we have 4 people, and Krish, Lavanya, Rajan, Ratna. So guys, please mute your mics from your end, and one by one please introduce yourself. We'll start with Krish Gowda. Okay.
Okay.
Please carry on.
Do you have someone, or anyone can speak? It's not like I need to know from everyone. Just a brief background, because I'm not able to hear anyone.
Hello?
Yep.
Yeah, okay, I'll introduce myself first then.
Uh-huh.
So, my name is Lavanya, and I currently just did my master's in computer science from California State University, Sacramento.
Okay.
And about this course, I basically kind of don't, I just have the basic knowledge. Just like what it is, Hadoop and stuff, but I'm looking for more details as to what exactly can be done and how development can be done in this area.
Okay.
Because I'm looking to going deeper into this area. I'm looking for job opportunities in this area. So, yeah.
All right. So, you have done your master's in computer science. So, any prior work experience do you have prior to your master's or something?
No, I don't have. That's why I'm looking
Okay.
for training.
Okay.
Yeah.
Okay. All right. Okay. Okay, Lavanya. Yeah.
Like actually,
So
I have work experience. I've done internship for 6 months, but that was in .NET. So it's like completely unrelated. Yeah. So yeah.
Okay. So, you are looking from the development perspective, to do how to do Hadoop programming and how to store data. Okay, fine. I got what your requirement is. So I'll take it up once I proceed with the demo. All right. So anyone else, or should we get started?
Krish Gowda, are you there? Hello, Krish. You there?
Yeah, I'm here.
Krish, can you please give your small introduction so that we'll start?
Yeah, hi there. I have around 10 years experience in IT. I started as Unix programmer, then I moved to SAP, I did some app work, and then I later moved on to functional area in SD and CRM. So now I'm looking into exploring a new venture. Basically, big data, it kind of enticed me very much because it has a lot of opportunities. And also, so that's basically that I'm looking from my end. I'm open to both the admin, developer, or anything, and basically I want to get hands-on into this big data concept, especially Hadoop. I know that Hadoop is a framework, so that's why I'm here to learn more and see where I'm standing and how I can use this opportunity to develop my career.
Cool, I got your requirement. Okay. All right, Satish. So shall we get started, or do we have anyone else?
We have Rajan also. Rajan, can you please give introduction of yours? Rajan, you
Yeah,
there?
sure.
Please go ahead.
Basically,
Yeah.
yeah, I'm not an IT guy. Actually, I have a background of pharmacy, and I'm looking for a SAS, Statistical Analytical Services, training.
Okay.
And so I just joined the demo for today, and then I'm looking forward for SAS, clinical SAS actually.
All right, right. If you're from a pharmacy, you definitely look for a clinical SAS. So, like, how come for Hadoop here? Because like SAS and Hadoop would be a bit
Yeah.
different sort of a thing.
Rajan,
I
basically it's a Hadoop demo. It's not a SAS demo.
Right.
Maybe, yeah. I think you got the wrong meeting details, Rajan. I think.
So I can like we can have a separate SAS demo because I do take training on SAS as well. So we can have separate demo on SAS. But this is for
We'll
big
do that.
data.
We'll do that after the maybe we'll plan for a SAS demo after this demo.
because
Right.
I got an email from Srinivas regarding the demo class, but I looked it up and I was like, I'm not familiar with anything regarding big data
Yeah, I
and
got it.
stuff.
I got it. Yeah, no problem, Rajan. Yeah, I'll talk to you again. Okay. Hey,
Yeah.
Okay.
Rajesh, you there?
Yeah, I'm there.
Hey, Rajesh, can you please give me your small introduction so that we can kick started with the demo?
Yeah, I'm presently in US and I'm H1B. I'm looking for converting. I'm working presently into the R&D sector of pharmaceutical field. I'm looking into moving into the software. So I was thinking this is one of the major field which is coming up in the market. So I thought let's get introduction to get an idea about whether it's suiting for me or not.
Okay. All right. All right. So thanks, Rajesh. Yes, Satish. So anyone else we have, or we can get
I
started?
think we have another person, Ratna Kaja. Ratna, you there?
Yes, yeah, I'm there.
Hey, Ratna, please give me your small introduction so that we can start the session.
Sure. My name is Ratna. I'm still pursuing my master's in computer science in San Jose. And I have a little bit of overall knowledge on Hadoop, and that's it. And I joined this demo today just to know, how Hadoop works and the overall working and a bit depth of Hadoop.
Okay, great. Okay, Santosh, we'll start the demo. Okay.
Yeah,
Please
sure.
carry on.
Yeah. All right, guys. So I'll get started with the demo. Yeah, as I got to know from a couple of you folks that you have a brief background on what is Hadoop all about, Hadoop or big data, because these go synonymous. So you have a bit background, but for the few folks who don't have any background, I'll just go a bit step back and tell what is Hadoop all about. Okay, so yeah, there are a few slides which tells about what is Hadoop, but if you see, the main triggering factor or the main reason why we are into like a buzzword called Hadoop is okay, if any questions please. Yeah, so the main reason why we have Hadoop on a plate, or like why there's a buzzword about big data or Hadoop, is the huge amount of data which we have around us today, like the humongous amount of data in terms of social media, or be it like multimedia platforms like Instagram or YouTube and all those stuff. So what is the reason which triggered this Hadoop, and why is it growing fast in the market? I do have few slides which will tell about those, but what I prefer doing is like with a example, I like to explain like where does Hadoop lie and what we have. So if you see earlier, well, like not earlier, nowadays also we had a legacy system wherein, like if I take an example of Walmart, okay, so you'll have a customer table, examine that you have a customer table which will have your transactional data, which when I say transactional data, which means that I went to the shop, I made few transactions, and that entered into a system. Okay, so then when the entry goes into a billing system or a particular database. When I make a transaction on Walmart, it goes into a table, like a relational table, and it will look something like this. Like it will have my customer ID, then it will have my like customer name, and then probably like what all products I bought, and like amount I spent, and like let's say store from which I purchased, the Walmart store from where I purchased, and let's say the purchase date. Okay. So these are few attributes which get stored into a table when I make a purchase at a particular Walmart store. Okay. So give me a second. All right. So this is something which is known as structured data, that you will have rows and then you'll have columns wherein, like let's say for a customer ID 1, 2, 3, you will have like whatever name, product sold, like how many products he bought, amount how much he spent, and like whatever. So all this information are customer specific, which are stored in a particular database. And the reason why these are stored, because see, Hadoop or any other like data warehousing project, or like any other IT project in general, it mostly deals with business, because all the projects which we do in our IT environment is like driven by business. So the reason why we have Hadoop or we have any other data warehousing project is to answer business questions. Unlike other projects like related to .NET or something where we build applications, a project in a business intelligence environment or a data warehousing environment or in a Hadoop environment is mostly hovering around answering business questions. So let's say you have a store manager sitting at Walmart. He has a question like, I want to know the customer details who has done the highest sale for a particular date. Okay, so what will this particular question, like you'll have this question. This question will flow downstream to like IT guys that, okay, I need an answer to this question. So the IT guys will go to this table, do a query, and then they'll come up with an answer. Okay. So this was a question which was answered through set of tables, set of database tables. Like I'm writing in bracket relational, because when I say relational, it means that structured data. Structured data as in like you'll have data in the form of these rows and then columns. Okay, so you'll have, when the manager wants to answer to his business questions, he has fired this question to the IT guys. The IT guys will have a set of tables in turn as their IT infrastructure, and then they'll be using few reporting stuffs or like analytical tools to get these business questions answered. Okay, so like you'll have reporting and analytical tools to get these questions answered. Okay, so like you have business objects as a reporting tool, you can have, as you said, like SAS as your analytical tool. So these tools will analyze or cook this data which is sitting on these tables and answer his business questions. Okay, so this is what is happening in the world. Like it was happening around let's say 5-6 years back when Hadoop was not completely into the market. Okay, so you'll have tables and like and then those tables will, like the data from these tables will flow to reporting layers, and then the business questions will be answered. So, and why the need for Hadoop came in after that? Okay, so if you see that I want to study trend. Okay, fine. If I wanted an answer to the question that who is the customer just purchase, I'll go get an answer straightforward from this particular table. Now I wanted to know a buying pattern for a particular customer. Let's say we have a customer ID 123 who is making as I see from his behavior that he purchases like he's a small ticket purchaser, a small ticket buyer. When I say a small ticket buyer, it means that he purchases for, let's say, like a bucket of $30 to $40 only. So I'm studying his pattern, that how is he behaving, like what is his buying patterns, or what is his customer trend analysis and all those stuff. So earlier we used to do our customer trend analysis or study of customer buying pattern by just looking at these relational tables. Okay, now what did managers come up with? Like, we have huge data in terms of, like, with the advent of social media sites like Facebook, Twitter, you can say Instagram, or like YouTube. With the advent of these stuff, we had huge amount of data sitting out here as well. Okay, like this was there, like relational tables where data will be in row and column. This was already there, but with the advent of these social media and the multimedia platforms, we had huge amount of data sitting out here as well, apart from what we have here. So let's say Walmart launched a product, let's say Walmart launched 5 products in its stores, and it promoted those 5 products on a Facebook page. Okay, and this particular customer ID 123, he liked 3 of those products out of the 5 which was promoted on Facebook by Walmart. Okay, so what will Walmart go ahead and do? That it will take its Facebook page, okay, and do a customer trend analysis on that particular information to see that, okay, fine, out of the 5 products which I bought, this particular customer is more inclined to buy these 3 products. So I'll go ahead and do a direct marketing to him. I'll send him mails, I'll send him SMSs, or I'll like call him to like throw him some offers on these particular 3 products because he liked those products on Facebook. So nowadays what the change has come in is that people are studying sentiments, or people are studying buying pattern, not by just looking at the legacy databases, but by even looking at the unstructured data. When I say unstructured data, it's about data in our social media platforms or multimedia platforms. Okay, so this is where Hadoop came into picture, when we started dealing with unstructured data. Okay, now here you have like this is your structured data, and now you have unstructured data. So earlier you had various tools like ETL tools like Informatica, or you had Oracle, or you had Teradata, and all those ETL tools which will take care of your data transfer from a particular relational table until this reporting layer to answer these business questions. But when this unstructured data came into being, we didn't had something which can take care of our unstructured data. Okay, we didn't had a particular technology in place to manipulate or give meaningful insights from unstructured data. There in Hadoop or big data came into being to take care of these unstructured information. Okay, so now what we have, like we'll have a set of relational tables which will give me like this information. Then you will have unstructured data as well, which will like do analysis on your unstructured data. Then both these data sets or both these information can be like incorporated or integrated into one reporting layer, and then these questions will be answered. So what's the benefit of integrating this unstructured data? It will give you more meaningful or more robust business answers. Okay. Because we have huge amount of data sitting in this unstructured platform, and why not make use of that data? Therein where your Hadoop comes into being. Okay, so if I go back to the slides, this is what we mean when we say like the explosion of big data, because we have data in like various platforms sitting everywhere. So why not exploit, or like why not use that data? This is where we talk about Hadoop. We have like 12 terabytes of tweet coming in every day, and then we have around 30 billion tags coming on Facebook every day, which was like 1.3 billion in 2005. So this is what, like, I'll not go through each and everything, but like this is why we came up with a need to have Hadoop in place. Now, if you see, like data was growing exponentially. In 2011, we had like around 1.8 zettabytes of data in Facebook, and now we have around 27 like it's expected that in 2015 we'll have 7.9 zettabytes of data. So we are seeing that there's a like constant increase in terms of data, and it's growing exponentially. So yeah, it doesn't mean that if the we have 7.9 zettabytes of data in 2015, all data would be like giving me meaningful information. But a fraction of it, let's say 50% of it, will definitely give me meaningful insight about how the customers are behaving or about various attributes of business. Okay, so to exploit that data and to use it forward, we have Hadoop in place. Now, as I said about these two slides, that we have 30 billion RFIDs, we have 12 plus terabytes of tweet, and like hundreds of millions of GPS enabled devices sold annually. So what comes to a student's mind is like Hadoop or big data is all about volume of data, or like big data stands for huge volume of data. But ideally, big data is not about volume of data. Okay, so if you go to this slide, what is big data? Big data, it doesn't refer to the amount of information which is being stored, but it is a concept which tells us how this voluminous data can be stored and processed downstream. Okay, so it's not about, when we say big data, we have a general notion which I have seen in my classes, like people think that, okay, big data means that huge amount of data. It's not about huge amount of data, it's about how you manage or how you manipulate or how you take care of that big amount of data. It's like a concept, it's not like something physical, but it's a logical thing, big data. Okay, so yeah, and Hadoop is something which physicalizes it, or like which implements the concept of Hadoop, big data. So if you see, big data is a combination of transactions, interactions, and observation. So as I was already explained with that example, that earlier we had just like transactional data, which we see in a particular table, that a relational table will have customer information all. So earlier we just had transactional data, which will contain OLTP and OLAP system, like these are data warehousing specific terms, which are like for current like data and for data which are stored for like history analysis purpose. So I'll not go about what is OLTP and OLAP now, but just to information, like transactional data stands for data which are stored in tables just for like analysis purpose. So we had big transactional data earlier as well. What new came into picture is interaction data. Like now we have social media sites and all those stuff. So as I explained that, we have interaction data and big transactional data, both when combined is taken care by big data integration, and then further processing is done to incorporate these two like flows of data to get a meaningful business information. Okay, so let's see. Okay, yeah. So most important factor, because like the first class, or when we take or start off with the normal classes, the first thing which we tell to students is like big data has three pillars, or the three V's of big data. Because like I am even a interviewer for my current organization in big data, so the first question which we ask to the guys who come for interviews, like what are the three V's of big data? Because this is where the whole logic or the concept of big data lies. That the first one, variety. As I said, like we have big data stars in various platforms like transactional data or Facebook or Twitter or any other platform. So we have data setting in various sources. So when we say variety in big data, it means that how can we manage the complexity, or how can we manage data in various sources. We have Facebook and we have a relational table. Let's say we have something in Oracle and you have something in Facebook, and you want to integrate those two things to come up with a solution. So when we say variety, it means how we can integrate data from various sources. And second is velocity, which means that how to increase the processing speed, or how can we take care that large amount of data can be processed or can be transferred with in less amount of time. So this is about velocity. And volume, like it's self-explanatory that how to take care of huge volume of data. So big data is about how to incorporate variety of data, or like data from various sources, how to integrate data from various sources, and then how to make that integration fast, which is meant by the term velocity, and how to take care of or how to manage this humongous amount of data. So big data hovers around these three principles of variety, velocity, and volume. Okay. Now, yeah, this particular thing I already spoke, like where does Hadoop fit in the whole data warehousing or an enterprise data cycle part. So we have like BI tools, which like BO and SAS, as I told, and like if you want to do analysis and reporting, Hadoop comes in here, because you capture data from various sources, store it, and then for and by using reporting on an analysis tool, you report or provide business answers to the question. So as I explained in that Excel, Hadoop fits in here when we are when we are integrating, or when we are capturing data from various sources. Hadoop fits in there in an entire enterprise data lifecycle scenario. Okay. Now this was brief about what is Hadoop. Now I'll go into couple of concepts about HDFS and MapReduce. So what are these terminologies, and how do we work on this? Okay. So as you guys might be knowing that Hadoop is an open source, and that's the more important reason that why enterprises are shifting to Hadoop in order to save millions of dollars in terms of licensed software. So yeah, but when we say open source, it doesn't mean that Hadoop completely comes in free and like we don't have any maintenance cost or something. But Hadoop mostly relies on commodity servers. Okay. When I say commodity server, I'll just explain you that with an example. Okay. Now I'll just go back to my Excel, and I'll talk about HDFS and MapReduce. What are these all about? Give me a moment. Yeah. When I talk about HDFS, and then we have another term called MapReduce. Okay. So when I say HDFS, HDFS stands for Hadoop Distributed File System. Okay. So whatever processing we want to do, we need to do if you want to see in a particular PDF file how many occurrences of a particular word comes in. Okay, so that can't be done on any other environment. So we need to take a particular PDF file into a Hadoop environment and then do further processing. So when I say Hadoop Distributed File System, or HDFS, it means that we are going into an environment where Hadoop will start working. It's all about that. Like in a layman's term, Hadoop Distributed File System is nothing but an environment where we need to land in first, and then we can start playing around with Hadoop. Okay, this is Hadoop Distributed File System. And yeah, going into a brief architecture, like how Hadoop works. Okay, so I'll explain that with an example. Now if you see, I'll take an example of unstructured information. Like let's say I wanted to download a particular movie from YouTube. Okay, I didn't get the whole movie at once. I got it in parts. So I had like movie1.avi, I had movie1_part1 in, let's say, AVI format, and I had like movie_part, like same movie, second part was in different file. Okay, now how does this go and sit in a HDFS platform, and how we access that information and how we take it forward? So if you see Hadoop, as I said, like Hadoop relies mostly on commodity servers. When I say commodity servers, it's like less cost or like less expensive small servers which we can use in order to store our information. Okay, so assume like you have Amazon Web Services. Okay, and it wants to store, like on a particular day it had 10 GB of information flowing in from various places. Okay, I had a server one. These are all commodity servers which are like which will have less storage capacity and it will be like less costly as well. So let's say you have 4 servers at your data center. Okay, you had 4 servers, each with a capacity of 4 GB or like you say 3 GB. Okay, and I had 10 GB of data flowing in on a particular day at Amazon Web Services. Okay, so how will that data reside in a Hadoop environment? Okay, you had 4 servers and each server had a capacity of 3 GB. So what will happen that this 10 GB will be distributed based on some logic among all these 4 servers. Okay, you'll have like 3 GB of information will be stored here. Then you have like let's say around 2 GB stored here. Then you have this particular server where you have another 3 GB of information stored. And then you have here where you have another 2 GB information stored. So this 10 GB which came in from Amazon Web Services got split into various commodity servers and was stored. Now again, let's say on the second day you had around another 5 GB of information flowing in, another additional 5 GB of information flowing in. Then I'll see that are these 4 commodity servers capable of handling that much data or not. Okay, so we have like 1 GB left here and 1 GB left here. So I can put in those 1 GB here, but the rest 3 we don't have information, like we don't have storage capacity. So herein I can add one more commodity server to my existing architecture or existing infrastructure, which will store this particular 3 GB here. Okay, so with this distributed feature, what happens, like we don't like we need to add servers or we need to add storage capacity as and when the requirement comes in. Earlier what was it, like a particular enterprise will purchase a server which will be like 200 terabyte or like 1000 terabytes of information, which will have 1000 terabyte of storage capacity, but ideally enterprise will not be using it. Okay, like you have a server sitting at your data center which will have a storage capacity of 1000 terabytes, but you're not using it, and you're just paying it for the maintenance cost and all. So that means you're paying for the you're paying for something which you're not using, right? So with the advent of this distributed Hadoop distributed system, what happened that you can add on to your storage capacity as and when the need arises. Okay, so as you saw here, like we had 4 servers. Now when a need came in for a 5th server, I added it. I added a commodity server, and like some tweaking will be done in our administration, like by the admin guys, and it will be up and running to store or to process the information there. Okay, so this is about distributed file system. Like we have information sitting in different servers, and we need to fetch that information to take it forward. So this is about a brief architecture of Hadoop, how data sits in various servers, and now how does a mapper or a reduce function plays a role here. Okay, so as I told, like I had a unstructured information of a movie one, like we had this movie part 1 and part 2. Okay, now if you see, when I'm storing this information in a Hadoop environment, how does this get stored? In order to, like, before a particular information goes into a server, there's a mapper function which plays a significant role here. Okay, what happens that these two files are present. Now I need to place these two files in my servers. So I can't like just on the fly it will be pushed onto any particular server, right? There will be some algorithm or a logic going in behind. Based on that, these files will be promoted to any of these servers. So this particular feature or a function mapper takes care of traveling or dumping your files to a specified location. What will happen that this particular file will go through this mapper function and it will get information that okay, you will go and set in server 1 and you'll go and set in server 2. Okay, and a particular unique identifier will be assigned to it. Unique ID will be assigned to this thing and this one, like sorry, that okay, unique ID will be assigned for both these files. Okay, now what will happen that a mapper function told me that okay, this particular file will go and set in this server. Okay, part 1 went and sat here and it had a unique identifier, let's say 1 2 3 4 attached to it. Okay, again I had this particular part 2 which had to go as decided by a mapper that this needs to go to server 2. It went to server 2. Okay, part 2 dot AVI, it went to server 2, and again it also had a unique identifier, let's say 1 2 4 5 or 5 6 assigned to it. Now a need came in that from me or from a particular business manager that I want to view these I want to view the whole movie. Okay, I don't want it in parts, I want to view the whole movie. This is where the reducer comes into picture. What will reducer do that based on the key columns or based on the identifiers which we have identified here, it will go to these two servers, server 1 and server 2, fetch in those two files, okay, part1.avi and part2.avi, part 1 and part 2, okay, it will fetch in these two files, combine it into one, and then it will be processed forward. So a mapper or a map function is used to segregate or distribute your files across different servers, and your reducer is used to consolidate or integrate those files from different server and present it to the downstream system. By the term downstream system, I mean that whoever wants to do analysis on that data or want to like do analytics or reporting on that data, so that can be forwarded downstream. So a mapper is used to distribute data across various servers, and a reducer is used to integrate data from those servers and take it forward. Okay, this is about mapper and the reducer function. So HDFS stands for an environment wherein we need to go ahead and do our Hadoop processing or whatever in calculation we want to do in HDFS. It happens in HDFS platform, or HDFS is the environment, and then we have a mapper and a reducer function. Okay, so this particular map and reduce thing, it mostly happens in Java. Like map function and reduce function mostly works on Java, but since most of the layman like Hadoop or Apache Hadoop, they wanted to keep Hadoop to be usable by a wide variety of audience. So they didn't want to, because my MapReduce programming deals mostly with Java programming, so they didn't want to keep Hadoop just for people who know Java. Okay, so they came up with various flavors like Pig, or you can say Hive, and there are like other flavors of Hadoop like Scoop and Uzi. So I'm not going to the details of what are these, but these are something which simplify MapReduce programming. Okay, so we had MapReduce earlier, which will just be done through Java programming, but we came up with different flavors of Hadoop, which are Pig, Hive, Scoop, and Oozie. These flavors like make this Java programming into simple user-friendly icons or simple user-friendly SQLs. Okay, like it's easy to write SQLs in terms of like if I want to view a table, I'll do a select star from a particular table, like select star from customer, where customer ID equal to 1, 2, 3. Okay, so when I talk about Pig Hive, they make MapReduce programming into simple human readable format. So now Hadoop is not all about Java programming. Okay, we can learn Hadoop and we can learn Hadoop development and proceed with Hadoop development or Hadoop admin by just having knowledge on Pig, Hive, Scoop, and Oozie. Okay, so people who know Java programming, it's good for them to learn like MapReduce programming because it doesn't require an advanced level of Java knowledge. It's just like if you have a basic level of Java knowledge, you can go in MapReduce program. But even if you don't have much knowledge onto Java programming, you can certainly work on Hadoop projects by just learning Pig, Hive, and these are few features like Scoop and like Oozie and all those stuff. Okay, so what these do, that they are a wrapper on top of MapReduce programming and all. So these are wrappers which simplifies the complexity which was involved in MapReduce programming. It gives like a, I'm not sure whether I have a VMware on this laptop to give you a demo, because I could have shown like how a Pig and a Hive. I'll just see whether I have yeah, because I just switched to okay. So probably you'll be given, like when you start off with a normal class, you'll be given a VMware player, and okay, I have some issues in this laptop, so I'm not able. So you'll be given a virtual machine, and like Cloudera will be installed on that virtual machine, and then we can get along with the hands-on on there. So there I can show you like MapReduce programming and the difference between a MapReduce and if you want to do the same programming in terms of Pig and Hive. Okay, so these will the complexity level in terms of MapReduce and Pig are very different. Like a complex program which will have like a 50 lines of code in MapReduce, in SQL it will be like in Pig or Hive it will be very simple. It can be interpreted very easily by any layman who knows simple English. Okay, so okay, I'm not sure. Okay, yeah, I can show you these things when I'll start with the normal classes. So we'll be getting a VMware player which you will be installing on a system, and which will have a Cloudera software installed on it, pre-installed Cloudera software, and that we can use it for our hands-on purposes. Okay, so yeah, this was about MapReduce programming and about Pig, Hive, and so that's the reason why we have our course structure designed in such a way that we talk most about, like once we are done with MapReduce programming and all those stuff, we talk most about like Pig, Hive, Flume, Scoop, Oozie. These are more user-friendly stuffs which takes care of your Hadoop development part and even for Hadoop admin, because like whatever I told in this part, these servers and about how to fetch and all. So this is mostly related to Hadoop admin. Okay, so and like when we want to integrate that information, it is done through mapping and mappers and reducers, which will use these technologies of Pig, Hive, Scoop, and Oozie. So if you see our course module, it will have mostly into like Pig, Hive, Flume, Scoop, and Oozie, which are various ways to interact with unstructured information. We can certainly Hadoop certainly support structured data, but mostly we'll be doing our hands-on on unstructured information, because that is where like the real power of Hadoop comes in. So these are the topics which we'll be covering, and then like VM will be set up and will be taking care of hands-on on Scoop, Flume, and like Hive, Pig, everything, and then yeah. Going into the MapReduce API, so we'll have Eclipse. This particular VM player, it contains Eclipse. Eclipse is like a tool where we can do MapReduce programming also using basic Java. So I'll devote like a half a class on the basic terminologies of Java, and then we can get into the MapReduce programming as well. So we have inbuilt software Eclipse installed on Cloudera, which will take care of our MapReduce programming. Okay, and then we'll have like Pig Hive and all those stuff, and then while entering into the end of our classes, we'll be covering few administration topics as well in terms of like how can we install various nodes and data nodes and all those stuff. So this was about like a brief demo about how the topic will be and what is a brief background about what is Hadoop all about and what is MapReduce and HDFS system, and about what the course curriculum will be all about, and so about where we'll be doing hands-on. So this is about all about the demo which I was planning. So any questions you guys have?
Santosh, it's Krish here.
Yep.
Thanks for the intro. It was a good one. My question is on the job profile. What is the main what do you call the functions or the day-to-day your work will be in when you're working? So since you said Java is kind of optional, since we have some add-on tools, do they require us to have like a excellency in the Java, or otherwise if I know how like whatever that Scoop, Hive, OZ, that should be enough?
The main reason why Hadoop or big data came up with these features of Pig Hive and like Uzi and all those stuff is to get rid of MapReduce programming. And when I say getting rid of MapReduce programming, it means getting rid of Java as well. Right. So when we talk about, to answer your question that do I need to have a background on Java, I'll say that you don't need to have. If you want to work in a Hadoop project, a Hadoop development project, or a Hadoop admin, you don't need to have a knowledge on Java programming, because we have these add-on tools which will take care of that stuff. Right. These are specifically designed for that purpose.
Okay.
Which are certainly like a replacement for MapReduce programming using Java.
In some of the job requirements I saw, they say that they had to be proficient in Java programmers, and also in add-ons that say that you should be knowing the what is that Uzi and Scoop and everything. I was a bit confused on that part.
Yeah. So why they say that? Because like if you see like when we started off with a like IT career or something, people say that we need to have knowledge on C++ to get started on anything. Like when we started off with the interview, they told that yeah, you need to have knowledge on C++ to do this for loop, while loop, or whatever. So when we say about Hadoop, people think that yeah, people have a general notion that we need to have a Java programming knowledge because MapReduce is all about Hadoop, but it's not. It was certainly like if you say 3-4 years back, MapReduce was certainly the only thing to do in Hadoop, but because of the complexity involved and because of the limited audience it had, Hadoop came up with these platforms. So now whatever we are doing out here, it can be done here. So when we say that in a job profile we have MapReduce programming, it certainly means that that particular project will be using Pig, Hive, Scoop, and Uzi as well. Because I'll say one thing, like a couple of years back, I was involved in a Hadoop project with Apple. So what happened, like we were using MapReduce programming and all, and like we were struggling to find resources to work out there. Like we had a limited number of people who can do MapReduce programming, and like we did a model and then it went out of a plate because of lack of good resources. Now what happened with the advent of these things like Pigs, Hive, Scoop, and Uzi, what happened, like the number of Hadoop developers went on increasing because it was easy to understand and people like wanted to learn, and it was easy to learn as well. So we had huge number of resources flowing in terms of Hadoop developers. So what Apple did, because of the like resource availability, what they did, they introduced these stuff as well as part of their IT infrastructure. They earlier had only MapReduce programming license to them, but now they even have Pig, Hive, Scoop, and Uzi, and they have various vendors who can do their work in small cost. So what I mean to say here is that just to get their work done, businesses are moving from MapReduce to these smaller, not smaller, to these easily understandable add-ons to get their job done through vendors at a less cost. So the next the next step in Hadoop is all about these tools. Okay, but yeah, basic will be this thing. But if we are good in these add-ons, we are good to go in Hadoop development projects.
Thank you so much.
Yep, thank you. Any further question?
Yeah, I had a question about. Sorry, can I continue?
Yeah, go ahead.
Yeah, so I had a question about the map reducing part. So when you say it's like when it's reduced, it's combined. Like, is it combined like in a one single file, like one movie, or is it like just collecting those parts?
It's just collecting those files to process it further.
Okay, suppose like we have like a tweet. So the tweet is to be or not to be, and each character, like 2 is served in one server and B is
I can see keystrokes, and can you please can someone get on mute, please? Yeah, thank you. Yeah, go ahead.
Yeah, so suppose there is a tweet of some, and to be or not to be. So is 2 stored in one server and B in one server and something like that, and it's collected in one tweet at the end. So suppose there are multiple words of same type, like B is like 3 times. So is it stored 3 times, or just that word is given a unique character 3 times?
You're saying that a particular tweet had 3 characters. Can you come again, like, because of some background noise, I didn't get your question. Can you come again? What you said?
Okay, so suppose we have like a tweet or sentence which has like multiple words of the same type. So are they stored like in say like B? Suppose the word B is stored like 3 times, or is it like just given a unique character 3 times and just stored?
It will be stored 3 times. So what? As I get your question, assume you have a file. Okay, you have a PDF file wherein you have let's say a word. Let's say you have a word Hadoop occurring 5 times. Okay, you have a PDF file or a Word file which has a word Hadoop occurring 3 times. So your question is like, will this particular word Hadoop be stored 3 times, or will it just be stored once with a value of 3? Is that your question?
Yeah, that's right.
No, it will be stored 3 times in 3 different, because a mapper function will keep it 3 times, but when we will use a reducer function, we can calculate that how many occurrences of Hadoop are there in how many occurrences of the word Hadoop are there in this particular PDF file. That way we can calculate, but it will be stored as 3 different words.
Okay, so it will know the order in which it comes by the unique ID, right?
Yeah, right.
Okay, sure. Thanks.
Yep. Any further question, guys?
So I had another
Santosh, Krish here.
So like
yeah, any one of you can go ahead.
Okay, then I'll just ask. So so will there be any like development, like how the development is done, like practical
Yeah, right. That's what. See, that we have this tool installed. Right? I'll be forwarding this VMware player, and the sole reason of forwarding this VMware player is like to do some projects and get hands-on on Hadoop, because we have slides and I can go through the slides and get over it, but that's not how we do learning. So we'll be given this VMware player. You'll have like as I said, Cloudera and all installed. So you'll be practicing, you'll be doing hands-on on classes, and I'll be giving projects as well, which you can practice on your own. And then in the next class, probably you can get back to me and I can answer if there are any questions. So we'll be practicing projects as well, along with hands-on.
Yeah. Okay. Yep. Thank you.
Yep.
Is this certification makes sense for the, like I see that Cloudera has a couple of certifications for data scientist, admin, and specialist. Will it make sense to go for the certification?
Right, like certifications always do carry an added advantage. So yeah, because like Cloudera is gaining like it has already gained popularity, but like it is widely used nowadays in terms of our Hadoop environment. So yes, going to a certification on Cloudera is a good bet because it will give you an added advantage.
So with the training you provide, that will be sufficient to cover? Do I need to take any additional course to kind of go through that test?
The training should be enough, and like I have few dumps as well on Cloudera certification and all, so that can be forwarded, which will like take care of specific questions which we have in Cloudera, and that way we can you can go ahead with the certification. So this training combined with few materials should be good enough for your certification.
Excellent. Thank you, Sundar.
Yeah, thanks, Chris. So all right, guys, I think we can wrap this session up. So Satish,
Yes,
can we wrap this session? Yep.
yes, Santosh. Thanks for your demo, and I'll get back to you with the complete schedule, everyone. So thanks for joining the call today. Thank you. Good night.
Yeah, thanks all. Thanks, guys.
Thank you very much. Thank you. Bye-bye.